Okay, so yesterday we covered first hands-on for the X-array. Today we'll cover the second hands-on where we'll learn about a little we'll dealing with the same data set which we used yesterday, like the net CDF file for the rainfall, and we'll try to fetch more information with that data set and try to do use the group by function and how we can calculate the monthly rainfall and how we can visualize it in the using the leaf map as well in the spatial format. And and we'll also make few more bar graphs and bar charts and try to make pick few more information with the same data set. And I tried to make the hands-on for the RioX array, but there were some issue with my collab and uh, some libraries are not working today. So we'll be doing that hands-on tomorrow only once I fix that. Okay. So when I say climatology, so basically climatology is one of the terms that people use when they are dealing with environmental data set. Mostly it means that whenever you are dealing with any kind of a rainfall, temperature or precipitation kind of a data set and doing any kind of environmental analysis, generally you represent the data not in terms of daily values, you represent it in terms of monthly data or in terms of yearly data. So since this netcdf file contain daily data within it, like yesterday when we did the uh, plot of this using the district rainfall time series data, you can see that it's looking a lot of it's like crumbled and it's not very good for the representation purposes. So when it comes to representation and also when it comes to modeling using the netcdf files, we always make the it convert it into a monthly data and then we process it and we use it further. So for that term only, there are few function or few keys that in within Python they are already enabled. You just need to use it in order to get the desired result. So let's suppose we will be dealing with monthly data only for now. So we had daily rainfall data till now in our file, and for converting or resampling it into a monthly data, we'll be using the key name as 1ms, means month start. This is simply means that the monthly mean rainfall means averaging every single value for the whole month. Uh, like the daily values, you will just make it average and you will get a single value for the whole month for all the years that you have in your data. So as you can see here that we are doing the same using in district TS. I'll just first quickly revise what we did yesterday. Just a minute. So firstly, we installed all the libraries. After that, we loaded our netcdf data. Once we have our netcdf data loaded as an X-array, then this is the AY geometry that we loaded. So once you have two files, one is your AY geometry, another is your netcdf file. After that, you clipped it here. Just a minute. Yes, you clipped it using the netcdf X-array and the geometry. We clipped only the part which is lying inside the AY geometry. Once we get the clipped geometry from that, then now in this clipped geometry, we are now trying to process and like make few charts, bar graphs, and all those things. So we have this chips clip variable where we have this clipped geometry here. After that, once you have that, we created a mean here in this district time series. In this district time series, what we did, we created a mean of all the value so that now you have for every single timestamp, after mean for every single timestamp, you have only one value. So in this time series data, you have saved that particular value. And as I explained yesterday, that before mean, you had three things like you have had time and latitude and longitude. And there were many values for that. So this is the mean that you used to remove that latitude and longitude information dimension from your data, and so that you can have a single value for every single timestamp irrespective of the latitude or the longitude. Now you have reduced one of the dimension from your data. So since now you have only time column, and for every time period you have one single rainfall value, because for every single latitude and longitude you have just averaged it, or you have just make an average for that whole particular AOI geometry right now. So we are dealing with this particular data, district time series data. So using this district time series data, so if you just imagine what this data will contain, in one of the column, you have all the time, like let's suppose 1 January 1981, 2nd January 1981, like that for every single day, you have the data from 1981 to 2021. This data is from 1981 to 2021 for every single day. But you cannot like really make a bar graph or generate an insight or a slide, like a time series data. You cannot really make out of it, because if you have 10 plus years of data, how will you make a beautiful graph out of it and bring a beautiful and nice information out of it? So for that purpose, what we are doing, we are resampling our data. So for resampling our data, currently we are choosing that we will do a average of the month, like every single day of the month, we'll just average it out. So we have used resample, and then how you want to resample it. So I want to resample it monthly for every single day that is present in that month. So I use time is equals to 1 ms. And then we used mean, because I wanted the mean for the whole month. If I wanted a minima for the whole month, I could have chosen a min. If I wanted a maxima, then I will choose max, max. So, but right now I want an average value out of this. So that's why I use this statement. So the variable I have defined here monthly, because this is the monthly data now we are reducing from the whole data set. So now how your output will look something like, so like for every single month, for every single year, you have a single value in your data. So if I just show you that earlier, maybe your data was something like this. So for 1st January, 1st 1981, 1982, let's suppose, and 2nd January, your data was like this, like for every single day, every month, every year. But now it will look something like this. Uh, you can say month wise, like January 1982, then February 1982. This is how your data is now stored, because you get the average of every single day for that month. But do not get confused when you will like print this particular value. At that time, you will get the date as well. It will be visible, but date will only be first, but it is a monthly average only. So do not get confused that it is showing a zero like 1st January and 1st February 1981. So is it just the value of the first day? So no, it is not just the value of the first day. It is the average of the whole month. But in terms of representation, it will look something like the 1st January 1982, 1st February 1982. But this value will be the whole month average. Okay. So once we have this monthly average for every single year, now what we'll do, same thing will apply because we want to plot it. So we need to have a data frame out of, we have to convert it into a data frame from a X-array so that we can now do the plotting. So for making the data frame, same code monthly dot to data frame. Now name is equals to monthly rainfall. We added a new column that where should we save that new value that we created after doing the average of the monthly data, reset index, and this is how it will look something like this. So 1st January, 1st February, 1st March, 1st April. So you can now see that monthly averages get created and the value is stored here. So that's why I mentioned that do not confuse with 0101. It is not like the first of the month, it is the average of the whole month. It is just for the representation, because for storing purposes, for the date time format, it needs a date value as well. That's why it is stored like that. So now once we have the data frame, now we'll just plot this particular data that we created. So we'll import matplotlib.pyplot as PLT. Then plt.figure and figure size 5,5. This is just the height and width we are defining. And then we will define what data you want to plot. So we want to plot this particular data frame, monthly dot underscore df. So monthly underscore df, what should be in the x-axis, what should be in the y-axis, we'll define here. In the x, this is the key that you need to define, like the column name. So it is time. So time in Y, I want monthly rainfall, and the title should be this plt.show. It will look something like this. Again, we tried to create a monthly average, but it still look a little bit of congested. Why? Because again, this data is from 1981 to 2021. You can increase the size for a better view like this. The only thing that I changed in the plot is just this, the figure size. You can play around with this size as per your need, how you want to represent your data. So now it looks little bit cleaner, but not really big. And also it is like cutting your data. You can see that it is only showing you the data from 1981 to 2014, and it is not able to show everything, since it still, because also because it is not able to like adjust everything, and the data is still 2021 actually, so still it's not the correct representation. So ideally, for showing to anybody, you can show it like yearly. You can show if you want to still show the monthly data. So let's suppose I want to show it for the only for the like 1981. Uh, just a minute. I want to show for the 2021 year. So what I'll do, I'll create a subset. So we use the dot cell function to make a subset from the whole data set. So monthly dot cell and then time is equals to 2021. So we created a subset, and then we are now gonna plot this particular subset. So once you're gonna plot this particular subset, we are trying this time. This is just like a line graph, and I am trying to create a bar graph so that I get a better visualization. So I created a bar graph. What is the difference between that graph? Only thing this ax dot bar. Here for creating this line graph, it was like this dot plot. So it was just plotting. If I wanted to create a bar graph, I'll write ax dot bar. Within the bracket, I'll define this. The rainfall monthly, the value that I fetched from here, and from that, which particular key that you want to fetch. So I want to fetch the time key from there. So I fetch the time key dot dt dot string time. We are just converting the value into a string integer so that it's able to read that particular value, and then after converting that we are giving it into the values. Rest everything is same here. Now you can see that it looks something like this. So we have converted the from the time values, like time is look something like this, like this. So we converted the month into a string values so that you can represent it in a string format, and your bar graph will look something like this for the year 2021. If I change the value here, let's suppose I just picked some random year, 1985 4. Let's suppose. See, for in 2021, we have the data only for January, so it is showing only for January. And if I check for 2015, it is something like that. It is changing. So this is how you can plot the monthly data out of this. Next thing is now comes the actual climatology word which people mostly use in terms of environmental factors. This is kind of a technical term also. Let's suppose you want to calculate the long-term average rainfall for each month. When I say long-term average rainfall for each month, I mean we are doing the average of every single month throughout the all the years that are present in my data. Means if I'm talking about January, so from 1981 to 2021, for every single January month, we'll do the average. So now we'll have now only have let's suppose if you have 10 years, so we'll only have values from January to December, irrespective of the year, because we have done the monthly average over all the year of data. So now we are again making our data set smaller and smaller. So you will only have 12 values now. How you can get that? Simply same monthly variable that we derived before, monthly. Now we are doing the group by. Why we are doing the group by? Because we already created a monthly data where we already have monthly data stored in time dot month. From time dot month you can fetch the monthly data, and then we are doing the group by. So let's suppose like for 1981 you fetched January, from 1982 you fetched January, 1983 to fetch January data, till 2021 you fetched all the January data. You create used a group by function, so you created a group by like a separate list, January, February, like that you have created, combining all the years of data. Then you have applied a mean in that. So after doing the group by, now you are doing the average. So after doing the group by the months, if you are doing the average, you will get the monthly average for all the years that are present within your data. So in our case, our data is from 1981 to 2021. So we'll get the January to December monthly average value from 1981 to 2021 using this particular statement. Any confusion anybody have in this line, what I just said? Yes, no?
No.
So once you have the values, you got the value, we stored it in a variable called climatology. Now we'll just try to plot a line graph from this. So if you want to plot this, I wanted to add a marker at the every point. So I just added a marker and figure says this. So I just plotted all the values so that I know how long-term average of the rainfall is varying for every single month over the years. So this is how in this what all information I can get. So from this particular data, I can like derive the information like in this particular area in the month of December, like over the course of 20 years, like from 1981 to 2021, over the longer period of time, this is the month where there is like higher rainfall is happening because this is a monthly average over the years. So you can get a just over a decade of period, for the longer period you can get a like the final decision you can make out of this particular chart. So this is how you can get. Now we'll try to like fetch the anomalies. So mostly when somebody is dealing with environmental kind of a data, there are cases that your maybe your sensor is incorrect, or due to some unnatural event or some disastrous event in some area. So people do all these kinds of studies to understand the anomaly factor, because these anomaly factor will help you understand the events which are not supposed to happen but they are happening. Because of these reasons only people get to like give alerts to the people. Okay, fine, maybe if you are doing the earthquake study, so you will be able to trigger the alerts on the basis of such event that usually the rainfall in this region, or usually the landslide or the earthquake in this region is lying in 4.5 or average is 3.5, so any kind of a value. But in the last 10 years this average value is not like matching with the long term average value. So now we can deduce the information from this particular thing that okay, fine, there is some kind of anomaly happening here from last 2 3 years. So there might be a reason that landslide can happen or earthquake can happen. So if you want to understand such kind of anomalies, so we'll try to do the same using the rainfall data. So how you can like get the anomaly value? So we'll set a range that if from that range our value is lying like very up, very positive or very negative, so we will declare that particular point, or we'll declare that particular area as that this is a kind of an anomaly and which is not matching with the average value we usually get for the rainfall. So how can you compute the anomaly? So we'll have the aggregate monthly rainfall that we already have. We'll compute monthly climatology using group by that we already did. And then we'll subtract it using X-array broadcasting. So we understood about the broadcasting. So we'll try to do the similar thing here. Subtract it using X-array broadcasting means we'll fetch the actual average long-term value, and then we'll subtract with the actual monthly average of that particular value. And then once we get the subtraction, if the value is very positive or if the value is very negative, from that we'll try to compute that okay, fine, this is anomaly or this is not anomaly. Same thing I've written here, that how much each month's rainfall is differ from the long-term average for that particular month. So if the difference is very much, so that means there is some kind of an anomaly in the rainfall. If the difference is very less, so that means there is no such anomaly cases present. So we'll calculate the anomaly by simply doing the group by. Earlier in the climatology, what we did, we created a group by for every single month and we did the mean. But here, for calculating the anomaly, what we are doing the monthly dot group by time dot month, means we are creating a monthly group by value, and then we are subtracting that particular value by the climatology value. What is the climatology value? Climatology value is the value of the long term average value that we calculated. So if the difference of the actual month's average is very like different from the long term average value, then in that case that is an anomaly. So we are calculating that particular value and saving in the anomaly. I'll show you how it looks. And then I created a data frame. So because I need to have all the values in a data frame so that now further I can plot that value. So if I just show you how this data frame will look.
Mom, there is text error. You write anon.
Oh yes. Okay. Yes. So this is kind of a actual value that I have created, that I'm showing you here right now. And then we'll add in this data frame the anomaly value as well that we have calculated. The actual value means what is the actual value of the precipitation that we had in our data for every single day, like 1st January, 1st February, 1st March. This is how for the monthly average that we calculated from there. So because from the monthly data, we created a data frame and I added a new column here. And in that new column, I am showing you all the actual values for the every single month average that we created for every single year in this. Now in this data frame, now here we'll add a month column as well. If I'll add a month column, so just a minute, because right now in this you can only see the year, like the combined time you are getting. But if I want to just fetch the month out of that time and then show you in a different column, because this month you will need for plotting, for visualization and everything. Now you can see that now in your data frame you have time, you have actual values, and you have month values as well, like this January, February. So it is easier for you for calculations, for representation mostly. Then after that, now we are converting our climatology value to the dictionaries. Why I am actually converting this climatology value to dictionaries? Because this climatology value is not uh, ready to bring into data frames. So if I want to bring the climatology value to data frame, I need to first convert it into a dictionary. Then only I can like add it into a data frame. Because right now, if I just try to see that how climatology looks, so it is a X array data array basically. So to convert X array data array to a data frame so that you can have the value ready for the plotting and everything, I have to convert it into a dictionary like this. So to series to dictionary so that I can add index and everything in a same order, all the values get added to your data. So we first converted it into a dictionary. After you convert it into a dictionary, now we are adding that value into a into your data frame like this. So NMDF, if I want to add a new column, I'll add this here in this. I added a new column, climatology in this. After that, nmdf.month.map climate dictionary. I mapped all the dictionary to this. Why I fetched months here first? I fetched months here first because this climatology value will be on the is on the basis of the month. Just a minute. So I need to fetch the months first so that we can map the value of the climatology on the basis of the each month, because these climatology values are only 12 values, so they will be repeated in our data frame. So in order to put the correct value into the correct month, we are mapping on the basis of the months. Just a minute. If I just run this first. Now you can, if you see here that 315.3562, this value for the January month and this value for the January month is same. So we are actually, we have to repeat all the climatology values as well. So how you will repeat it? So we will repeat it on the basis of the month, because in climatology value, these precipitation value are stored on the basis of the month. Like for the first month, the value is 315. For the second month, value is 276. So from DF, we fetched the month column, and for each month column, we mapped it using the dictionary. So kind of you can say it like the key value kind of a pair. So that was the reason we needed to convert this particular thing into a dictionary so that we have a key value pair for our climatology data here. Like in the key, it will be month, in the value, it will be the precipitation value. So you will now map the month and the values using the key here into a new data frame. So I hope now you are also getting you are getting an understanding how everything is correlated. Like whatever we studied so far, like the dictionaries, pandas, data frames, geodata frames. So in these exercises, like yesterday's also, today also, in further exercises also, you are kind of using everything all together. So it's important, like along with learning the syntaxes, it's important. I feel that you have to build up an understanding how and when to use the concepts. So it's better that if you learn how to use the concepts, so you will be able to bring out very good analysis for yourself. So like similarly here, if somebody don't know like what is the use of dictionary, then you will simply skip this part and you will try to add on this climatology value to this data frame. And if you don't have an understanding of dictionary and how actually the data frame work, how actually the X array works, so if somebody has an understanding of all these things, then they will instantly automatically get an idea that, okay, fine, I needed to like attach a new column into this particular data frame where I have a month column as well. And in my climatology data, also I have two values, month and the rainfall data. I need simply to add on these values. So what are the best possible ways to add on the value? So best possible way was to just convert the value into a dictionary and then add into a data frame. So this is how you can get it. So now we have time, we have actual data, we have climatology, and once we have actual and climatology, we'll get the anomaly value as well. So we already calculated the anomaly value, and if we haven't calculated the anomaly value like this way, where just a minute, like here that I calculated, I could have calculated afterwards also. Like once I have this data frame, I can simply create a new column here, and after creating a new column, I can just use this actual minus climatology. This will also give me the anomaly value. But since we already calculated the anomaly, so we'll simply add on to our data frame. So here we'll add an anomaly column and anomaly dot values. We'll add it, and then we have everything sorted here. This is kind of a reordering. If you means the I want to reorder the column as per my wish. If you don't want to reorder, that's fine. You can simply leave it like this. Just run this particular line and just print this. You'll get something like this. But we already reordered, that's why it is showing you like that. But if you want to, let's suppose you want month at the start. Okay, this reordering actually works like this only. There is some issue with my Google Colab. It is not working today properly. But if you just reorder this using the same syntax, it will work like this here. Okay, this is the same thing that I explained yesterday. Now, the last thing that you asked me yesterday, how you can plot it using the leaf map into that, how you can plot the new raster into a using the leaf map. So let's suppose, just a minute. So for that, first of all, you need to save your raster into a TIFF file. Then only you can like plot it into a leaf map. However you want to plot it. So if you want to save a raster, so you want to first set a time into a 0, or you can also define a particular time here that you want to plot the raster for which particular date. So if you don't want to define a time, if you just want to make it default, so time is equals to 0 is fine. So time is equals to 0 will define a like it will fetch the first date from your data. So in our case, our first date is 1st January 1981. So it will only fetch 1st January 1981. But if you want to plot for any specific timeline or for any specific date, then you can just define the time here as well, and then select that value and then save that into a raster. So from my the clipped file, you will not take all these monthly data frame that we created in between. That was just for the plotting and everything. If you want to save it, we will take our main data frame what we created up just after the clip, and then from that we'll select, we'll define a time here because we are doing the subset from the whole data set. We are not saving like the multiple timeline of data into a TIFF because we cannot save it like that. If you want to save the multiple timeline data, we'll save it in NC format. But since we have to plot it in leaf map, we will use a single time data. So we'll run this and then we'll save that particular raster into a file. So for saving it into a raster, variable dot rio dot to raster, it will just save it into your Okay. You should try whatever I am teaching or whatever code is written in comment also. You should try on your own systems as well. This all will work because I have run all these things at one time, but they were running perfectly. But today only there is some issue with the library import. I tried to import few libraries for the time slider animation, and that is causing a conflict, so that's why it is not running. And if anybody will face issue in running anything or you get any error, you can send me the screenshot at that time only. Okay, so simply you need to save this raster. These both thing will work, either the time as 0, either that any specific timeline, and then you have to save it in the raster like here. And once you are saving it into a raster, now we'll use this raster to plot the leaf map here. So how will you plot the leaf map? Again, you need to import the leaf map library. Then you need to import the matplotlib pyplot. You can just skip this for now. And then matplotlib colors as m colors. This is because I wanted a color bar as well in my leaf map. So for adding a color bar for the legend purposes, this particular library I imported matplotlib.colors as m colors, and then numpy as np. I will show you why I use this, because I will create a classes here for the rainfall data, because since rainfall data is usually represented in classes in range, so I'll create a classes for my whole data, and then after creating a classes, we'll just plot it in that. I'll show this particular thing in different collab because there it is not working. One more thing, in the last session, when I told you about the rasterio and everything, I told there are few things which you need before using leaf map and collab, which is just a minute, this one. Pip install leaf map, local tile server RioTiler. This one library that you need to install, that should be there in your collab file one at least once. And then after that, this particular thing from Google Colab, import output.enable custom widget manager. That should be the first task one should be doing if you're using Colab for leaf map library. Uh, and then import leaf map. After doing those two steps, you will be importing the leaf map, not before that. And there is two things that sometimes they work perfectly fine, but sometimes you'll get issues, like you need to restart the session from here. Okay, so this is not activated right now in my case, but once you run these two two imports, one was this local tile server import, leaf map, and local tile server and RioTiler. These three imports, and after that you need to import this from google.collab, import output.enable custom widget manager. Why we actually need this? Because this leaf map library, actually the support is not very good for leaf map library, but I'm teaching you because I wanted that you should know how leaf map work. But we'll be covering another libraries as well for plotting and everything, which is Folium, and which is widely used, and it is more preferable in terms of plotting, and there are many support available for Folium libraries. And leaf map is causing few issues. I am also facing it like from last 1 week. But try to practice it, and if you also face similar kind of issues, I'll like try to rectify it as much as I can. Then we'll switch to another libraries if we feel that this is creating a lot of issues. Okay, so but two things are must. This widget manager you need to install, import first, and then you have to import your leaf map. And if it still doesn't work, restart the session once, and then after restarting, then try to create a map out of that. Okay, so once those two tasks are completed, now you are ready to plot your library, plot your any data that you have. So let's suppose we are defining the V minima and V maxima. Why I'm defining a minima maxima? There are two ways to define because I needed to create a slider here, and in slider I need to define the values that what should be the minima value and what should be the maximum value in my classes. Like whenever you used to do the classes or the symbology using ArcGIS and QGIS, there also we define the classes, right? In the classes, what should be the minimum, what should be the maxima. Similar thing we are trying to define here, the minima and the maxima. So there are two ways to define. One is that you can hard code. Another is you can fetch directly from the data. So since in our main collab file, when we were like creating the data, so we had everything stored in this rain. In rain, we fetched the time chip from chips clip file. We fetched the data for a single time period and saved it in rain. And then we can fetch the minimum and maxima value for this rain directly. This is how you can fetch it dynamically. That V minima should be float from the rain X array, fetch the precipitation variable, dot minima, dot values. This will give you the minimum value and this will give you the maximum value. And then once you have the minimum and maximum value, we just convert it into round off. We rounded off to a single digit so that it looks good for the legend values. So these two things that one needs to perform. But for now, for the time being, I have just written it hard coded here, but I commented this. You should try it like the in a dynamic way that one should fetch the minimum and maximum value from the data itself. You should never try to hard code things within your workflows. So once you get the minimum maximum value for your color bar, this is how we create a map. So first we create a map. When we are creating a map, leaf map dot map, we'll first define a center and we'll define a zoom. So center, you can define what should be the center and what should be the zoom level. Then we'll add a layer, what layer we want on top of our base map. So I wanted to add a raster file. So for that case, I used a function name add underscore raster. So this is the path and then the color map. Color map, we have defined what should be the color map, and then layer name as well. This layer name will go into the toggle, and anywhere we are showing the layer name and everything. Then here we are creating in the legend, as I mentioned. So when we are trying to create a legend, so here we define that what should be the color that should go into the legend. For that, the key is CMap. So in the CMap, you will define the color plt.cm dot whatever the color map that you choose here, you will choose here also. And in the color here, we are trying to create the classes for the hex map, and we use the for loop that it should do the loop over every single value that you have within your data, and you should break the classes from 0 to 6. You can see here 1, 2, 3, 4, 5, 6, 7. So 0 to 6, it has created the 6, 7, like 0 to 6 classes here in this. So you have defined this here. You have defined the breaks in this, and for that you needed a numpy library. That's why we imported numpy as well. And then simply m dot add color bar, define the color, define the minima, define the maxima, what should be the caption means what are the values. These values are in rainfall like this is the caption in the legend. So this is how your legend will now look like, and your whatever data that you clipped from for the geometry, that will be visible here. And try to run external. Also, one thing, when you try to create this leaf map, use it in a new collab. Do not use any like pre-existing library should not be there because it might create some issues. So this is how you will get the output. This is working fine in this particular collab, but in my main collab, this is showing empty. There is no error as such, but somehow it is not showing the result. So you can also test and try to create a separate collab file and then run it. There is another thing that from the same leaf map, if you want to have a HTML file as well, let's suppose you want to share it with somebody, you want to host it. So simply after that, you can add this line. This is how it will look. See, right now it is not showing anything from this collab, but from here it will show you. Just so after once you where you are writing M, you just have to just write m dot to HTML. You can define the path where you want to save the HTML. You can run this and download it. And you can just host in your Git or anywhere. Like let's suppose you want to create your own projects or anything, and you want to showcase your project in the form of a shareable link. So you can just share it like this. Okay, fine. So it is not visible here. We'll check why it is not coming. But the code is correct in this. The same code we'll use. There is some issues with the libraries only. There is some conflict happening in my collab. So we'll keep it till here only. Try to replicate the same in your own codes. And if you still, you also face the same issues in your collab while working with this, let me know. Then I'll try to. I'm also trying that. What is the actual issue? Is there any some kind of a version issue? Because leaf map is very unstable. For now, I only got to know today. So we'll move to a different library if this will create an issue. Okay. Any questions? Anybody?
No, ma'am.
Okay, and Omar, I tried to search your data that you shared. I couldn't find for now, but I asked other people as well. Uh, if they'll find, I'll share it with you. Okay.
Okay, ma'am, I will try to find it.
Okay. Okay then. We'll have one class tomorrow as well in the evening, and try to practice all these things because I want to just first clear any issues if anybody's facing in terms of the leaf map library. So I'll also try to find what is the issue with my collab, and you also practice so that we are all are in the same page. And if everybody's facing the issue with the leaf map, then I'll move to a different library. So try to practice this by tomorrow evening so that we can like have an idea what we should do further. Okay?
Okay, ma'am.
Okay. Or because I want you to create the interactive maps and everything for your capstones. Okay, Sally. Bye bye. Good night.